Greetings, this is Group 44 presenting on the topic Exploratory Data Analysis and Feature Selection for Parkinson's Disease Prediction. This project is being presented by me, Manisha KC, Minusha Gurung, Rijana Shrestha, and Mohammad Jubayer Hussain, and our student ID are provided here. For this project, we have used the provided dataset. Our first objective is to identify salient variables that can effectively differentiate between individuals with Parkinson's disease and healthy people. We have divided the project into four steps: data wrangling, which is subdivided into data loading, and data separation, which is used to organize the provided data in columns, statistical analysis for feature selection, and we have also done an extra step, PCA testing, to make our results more accurate and efficient. The first step, data wrangling, is going to be described by my friend Jubayer.
Thank you, Manisha. Hello, John. I am Mohammad Hussain, and I am going to talk about data wrangling. Data wrangling is divided into two parts. So, the first one is data loading. So, we use the data set that was provided, and we use necessary cleaning for the training, and we perform the t-test for the uh, to find out the PD and non-PD data from the data set. In the code, we perform t-test for the test CSV file and stores it in pandas data frame called df, and the columns attribute is then used to assign meaningful columns names to the data frame, providing context to each feature. The df function is employed to display the first few rows of the loaded dataset, showcasing the organized data. Then data separation. The code aims to separate the data into two distinct groups based on the classification level, indicating whether an individual has Parkinson's disease or not. The code drops unnecessary columns like subject identifier, using the drop function to retain only the features will be used for analysis. The label variable is assigned the PD indicator column, representing the classification level. Further separation is achieved by creating two data frames: PD data for individual with PD and healthy data for individual without PD. Finally, summary statistics, means, standard deviation, etc. for each group are calculated and stored in PD stats for the PD group and healthy stats for the non-PD group. The statistics are printed to provide an overview for the data distribution and characteristics for the both group. So now I'm going to talk about the t-test comparison. The code performs t-test to compare the values of each feature between individual Parkinson disease and without the PD. The primary aim to The primary aim of this t-test is to determine if there is a statistically significant differences in feature values between two groups. By conducting this test, the code assesses whether particular features exhibit different behaviors in individuals without PD. The main goal of conducting t-test is to point out features that show meaningful differences in their values based on whether individuals have PD or not. Features that exhibit significant differences can be indicative of attributes that might contribute is distinguishing individuals with PD from those without. Significant feature selection. After conducting the t-test, the code examines the p-values associated with each feature. The features with p-values less than 0.05 are considered statistically significant, and a p-value less than 0.05 suggests that the observed differences in feature values between PD and non-PD groups are unlikely to have occurred due to random chances alone. These features are selected as they have higher probability of contributing meaningfully to the distinction between the two groups, and the code employs t-tests to compare feature values between individual with and without PD. Significant features identified by the low p-values and considered potentially valuable for differentiating individuals with PD from those without. This analysis helps us understanding which attributes might play a role in the presence or absence of Parkinson's disease. Thanks everyone. Now Minusha is going to explain after me.
Thank you, Zubair. So, what I'm going to explain now is the working of code. So, box plot. So, the box plot for calculated data can be obtained as shown here. Through these, we can analyze and select the salient features that would separate the people with Parkinson's disease from healthy people. Uh, we got jitter percent and shimmer percent as higher values in PD group, and shimmer as absolute average, pitch maximum and pitch minimum as higher values in the healthy group. So we have also performed a t-test to extract the significant features by comparing with p-value, and it goes like this. Uh, the t-test would run as this, and we compared with p-value and got the significant features as this. Then we also performed a principal component analysis for dimensionality reduction, and we did this. This is the extra work we did, and we were able to visualize the data as here. The one is for people with Parkinson's disease, and zero is for healthy people. And we also tried to visualize the data in three-dimensional image as here. So now, why t-test and why Parkinson's? Why principal component analysis? So using t-test analysis, it can help in identifying significance, uh, effect size estimation, comparison of means, simple interpretation, quick assessment, and informed decision making. And for data wrangling, we have used principal component analysis. This is because PCA helps to reduce dimensionality and complexity of high dimensional data while retaining as much information as possible. So with this, we could select the most significant data efficiently. And now Rijana will explain the results and conclude the presentation. Thank you.
Thank you, Minusha. Through the analysis of previous steps, we have found that these five features, which are jitter percent, simmer percent, pitch minimum and pitch maximum, voice fraction, and voice degree, play a crucial role in distinguishing individuals with Parkinson's disease from healthy individuals. From the analysis, we have found that higher the jitter percent and simmer percent, it is more likely to have Parkinson's disease. Similarly, lower the pitch range, voice fraction, and voice degree indicates more likely to have Parkinson's disease. From the dataset, we came to conclusion that these five variables play a significant role to distinguish Parkinson's disease from healthy people. To summarize, we have used dataset to understand descriptive and interfacial statistical analysis, feature selection, and accurate data preparation played a significant role to predict Parkinson's disease from healthy individuals. In conclusion, we have successfully identified key features for Parkinson's disease diagnosis. After this, we can explore advanced modeling technique and gather more accurate analysis. Thank you.